We need to be able to bring the power and the persuasive capacity and the communication capabilities and the illustration capabilities of technology right into the classrooms.
We've recently been looking at computer-based training, and to make it successful, we've decided what we really need is digital full-motion video.
Well, we found with digitized video that we can quickly show a rough cut of an ad sequence to our client. And with a server-based solution, we can share those video clips with all involved.
Today's digital video customers are primarily concerned with stored video applications and how many simultaneous users they can have. They fall primarily into three categories. There's training and education, such as factory floor reference. Secondly, there's retail applications, such as point-of-sale systems and information kiosks. And third, database applications, such as an ad agency which wants to keep track of all their commercials, or any company that does a lot of video editing.
It has to work in a network. Standalone computers just don't do the job.
But they just don't seem to integrate.
1, it must work with the network we already use. 2, it must support lots of users. And 3, it must work simultaneously with other networked applications. Obviously, there are lots of challenges and potential bottlenecks.
Networking is a key component for digital video applications. Today's networks have been designed for data applications which are transaction-oriented. In contrast, video and other multimedia information are stream-oriented. Because of that, we face several challenges. In the storage system, we have to provide video data to many simultaneous users. In the file server, we have to provide sufficient processing power and bus bandwidth, as well as appropriate software. On the network side, we have to provide sufficient bandwidth and protocols which ensure reliable and timely delivery of the data.
Today's networks and servers were primarily designed to handle time-shared transactional type applications commonly found in business. When you add video and audio to these systems, they just simply can't keep up, and all applications suffer. But because StarWorks was specifically designed from the ground up to handle real-time streams, it will outperform normal systems in both functionality and performance. As a consequence, both video and non-video applications perform properly.
The StarWorks solution is based on a client-server architecture that delivers cost-effective performance for video applications. On the client side, the video-capable PC or Macintosh includes the application and digital video system, which provides compression or decompression in either software or hardware. On the desktop computer, StarWorks is the video networking interface. Starlight developed a Media Transport Protocol, or MTP, which supports video application services. MTP coexists with other protocols on the network. StarWorks works with the popular video formats like DVI or QuickTime and can handle multiple formats on the network at the same time. Existing local applications can be networked without modifications. StarWorks turns a 486 computer into a highly functional video application server. Arrays of Winchester disks are used for storing the data. StarWorks Storage Management uses a patented streaming RAID algorithm to stripe the data across the disks. Data is organized to provide the necessary access bandwidth to support a large number of users simultaneously. With StarWorks, users get no compromise access. All users can access the same video, even starting seconds apart, or they can all access a different video. Object management lets applications and system software address the streaming data as objects. This gives applications sophisticated control over the data. For example, a video may have an English track and a Spanish track, and the application can then select the track based on the user. Treating video as objects reduces the amount of storage required, provides greater flexibility in handling the data. Stored applications can access the data as simple files, thus allowing StarWorks to work with current applications. Stream management is essential for delivery of digital video on the LAN. StarWorks manages the connection between producers of video, like disk drives and cable feeds, and consumers of video, like desktop computers. The stream management function ensures that there is sufficient bandwidth, establishes the connection, and manages the flow of streaming data. In other words, StarWorks provides a PBX-like function on the LAN, a concept totally foreign to transaction-oriented network systems. Finally, StarWorks supports application services developed by third parties. These may include, for example, scalable video for altering the frame rate or resolution, or perhaps mixing of streams.
With StarWorks and a 486-based Starlight Media Server, we can provide digital video to up to 20 simultaneous PCs and Macintoshes.
After this turn, the course goes next to the pond. Finally, it goes in front of this oak tree to the finish line. Let's meet this year's runners. The tortoise, last year's winner. The goat, underground runner. Between the goat and the tortoise, it's the hare, anxious to beat the tortoise. Up is in the lead, and the rain is the goat is second, and the crow finishes third.
A single video file can be stored on the media server and accessed by all users at any point in the video. And StarWorks works with any network operating system, such as NetWare, AppleShare, NFS, or LAN Manager. In other words, StarWorks makes enterprise networks video capable.
With StarWorks, we manage and deliver full-motion video throughout enterprise networks by supporting the most popular video formats, the most popular desktop platforms, and the most popular network operating environments for any type of video application.
A Starlight Media Server may be configured in one of two ways, either direct connected through multiple Ethernet hubs or through switched hubs. Both take advantage of network segmentation using star networks with multiple Ethernets. These are common and cost-effective ways of ensuring adequate network bandwidth. With direct connection, up to 20 video users may access the media server over multiple Ethernets or through standard hubs. Video users still have access to their network data applications over the corporate network. A switched hub configuration allows even more users to be video capable. In this configuration, the media server is connected to the switched hub over multiple Ethernets, allowing dozens or even hundreds of PC and Mac users to be video capable. And like direct connections, users still have access to both video and non-video applications.
What we're seeing here, and this always gives me goosebumps when I think about it, what we're seeing here is the birth of a new generation of technology in American education. We call it, this new system, interactive media. The interactive media system uses the technology that you already have. It uses the local area networks that you've probably, that educators have already installed tens of thousands in schools all around the country.
Starlight's vision is to support the management and transmission of digital video throughout corporate enterprise networks. We plan to provide these services in data networks as well as the emerging teleconferencing networks. Our initial focus is stored workgroup applications that work with any network operating system. We'll be widening our support for other applications such as video editing and live teleconferencing, as well as connecting to wide area networks. And in the future, we hope to tackle campus-wide networking as well as new technologies such as ATM. StarWorks supports today's applications and provides a foundation for tomorrow. who deliver video reliably without compromise.
It's fast video going to a lot of different directions in a hurry. It's really nice.
I'm an absolute believer in this. I cannot see anything that is more exciting than what is coming down the road.
It's from a company called Starlight Networks.